Today's lesson is on connecting infinite limits and vertical asymptotes. Everything in this lesson, I think we've actually already discussed in this unit, so it's a little bit of a review. We're going to start by looking at this graph, f of x equals 1 over x minus 1. So as you can see, there is a vertical asymptote at positive 1. So we're going to look at limits around that area. So starting out, limit as x approaches 1 from the left, so one-sided. So of the function 1 over x minus 1. So from the left, it is approaching negative infinity. Okay, from the other direction, the limit as x approaches 1 from the right of the function, from the right, it is approaching positive infinity. So therefore, the limit as x approaches 1 of 1 over x minus 1 does not exist because it's approaching different directions from the left and from the right. Okay, now we're going to look at doing some more factoring and canceling and kind of review when does a vertical asymptote appear. So we're going to look at the limit as x approaches negative 4 of x minus 4 over x squared minus 16. So let's think about factoring the denominator there. I will have x minus 4 over x minus 4 times x plus 4. So the x minus 4 cancels, so remember that would be a whole at x equals 4. And then because this is left over in the denominator, there's a vertical asymptote at x equals negative 4. So now let's look at the limit as x approaches negative 4 of what is left, so 1 over x plus 4. Okay, so there's a vertical asymptote at negative 4. And kind of two options here. Either you're going to get really good at just memorizing what these graphs look like, or what we need to do is plug in values left and right to see if the two-sided limits are equal. So I'm going to look up as we approach negative 4 from the left and then negative 4 from the right. So if we do from the left, let's think about a number left of negative 4. So 1 over negative 4.01 plus 4. Well, that's going to be 1 divided by a very small negative number. So that will go to negative infinity. And then approaching negative 4 from the right, so that would be 1 over, let's do negative 3.99 plus 4. And that will be 1 over a positive small number. So that's going to go towards positive infinity. So because they're going opposite this up here, this limit at negative 4 does not exist. Okay, here is another example. The limit as x approaches negative 4 again, this time 1 over x squared plus 8x plus 16. So first let's factor the denominator. 1 over, that goes to x plus 4 times x plus 4, which is the same as 1 over x plus 4 squared. So the limit as x approaches negative 4 of 1 over x plus 4 squared. So same idea, we have to look from the left and from the right. Okay, so as we're approaching negative 4 from the left, let's plug in a number just left of negative 4. So 1 over negative 4.01 plus 4. So if we add that will be a very small negative, but we're going to square it. So it's still going to be a very small number, but that's all of a sudden going to make it positive. So 1 over a positive small number, that will approach positive infinity. And then the other way, 1 over negative 3.99 plus 4, well, that's already going to be positive, and then you square it, it's going to stay positive. It'll be a positive small, so they will both go towards positive infinity. So that means this limit equals positive infinity. And now looking at two examples where we are only going to consider one side. So as x approaches 4 from the left of negative 2 over x minus 4. So let's just plug in a number just left of positive 4. So negative 2 over 3.99 minus 4. This is going to give me a very small but negative number. So negative 2 over a negative small. Negative divided by negative is going to flip to positive. So that will approach positive infinity from the left. So we only have to consider the one side because it was just a one-sided limit. Okay, last example. Limit as x approaches negative 5 from the right of x plus 3 over x squared plus 8x plus 15. Okay, so let's first factor this. X plus 3 over x plus 3 times x plus 5. So let's just think about that for a second. So that's a whole at x equals negative 3 and a vertical asymptote at x equals negative 5. And that's where our limit is. And we're approaching from the right. So let's look at the limit as x approaches negative 5 from the right of 1 over x plus 5. Okay, negative 5 from the right, negative 4.99. So if we add those together, that will be a very small positive. So that would approach positive infinity. Okay, there is the full video looking at limits at vertical asymptotes. Good luck with your lesson.